Hello there. In this video, we're going to be talking about the general solution to natural and step responses for RL and RC circuits. Now, the general solution can help us with circuits that have sequential switching, where the switches on or off or in different positions. And just for you guys, just for a recap, natural response is you're finding the effect of the current and voltage of uh, uh, a capacitor or an inductor releasing its energy to a resistive circuit. For step response, we're trying to find the effect when we add an independent source, or independent current source, or independent voltage source to a circuit with a capacitor or an inductor and resistors. We're going to find what's its effect on the voltage and what's its effect on the current. Okay. Now here is the general solution I have here. I defined it right here, just for you guys to know. It's your unknown variable x is equal to your final variable plus the initial variable minus the final variable times e, the exponential, to the minus t minus the time of switching, which is t naught, divided by the time constant. In brackets, the time constant is tau from the last video. Okay. Now tau in RC circuits is equal to, remember, R times C. Now in RL circuits, however, tau is equal to L over R. Okay. Now, what do we know for this variable? How do we know? Do we search for currents or voltages? Well, here I have a little tip here. For RC circuits, choose the voltage, your unknown variable, as your voltage. So for RC circuits, you're determining the final voltage and the initial voltage, and also your tau. Okay, for RL, you want to find the current, the final current, and you will find the initial current and tau, L over R. Okay, that'll be steps 3 and 4 and 5. So, gonna look for the time constant. Time constant for this R resistor is actually R Thevenin's. And if you recall, R Thevenin's, to find R Thevenin's in some circuits, you might have to find V open circuit over I short circuit, okay, to find R Thevenin's, okay. I have an example here at the bottom where we apply the general solution for natural and step response, okay. Okay, so in this circuit, the switch has been open for a long time. Long time. This switch right here has been open. So we have this circuit here, and at t equals 0, this switch closes. And when the switch is closed, notice that the right side of the switch is the only important part, because this, when the switch is closed, is attached to ground, and this whole left side is a whole different circuit. It's isolated by itself. So when the switch is closed, we only worry about the right side of the circuit. Okay. First thing to do, let's look at our steps. For RC circuits, we choose capacitor voltage. For RL circuits, we choose inductive current. Now, what do we have here? What's our circuit? We have a capacitor and resistors and independent sources. So we have to choose a capacitor voltage as our unknown variable. So we're looking for, according to our equation, our final variable and initial value or variable. Okay, if you read this carefully, it says that we have to find the initial value of our voltage. Okay, so So this has been closed. This switch has this switch has been open for a long time. So for a long time, under steady state, capacitors pop open. So let's redraw our circuits. We'd have 10 amps, 5 ohms, 2 ohms, 4 ohms, and this, see, the switch has been open for a long time, so this part of the circuit is open, and we know that under steady state capacitors pop open, so this would be open, and so this would be 2 ohms, 4 ohms, and 6 volts. 6 volts. Okay. Let's label this A, label this B. We want to find our initial voltage right here through this capacitor. What's the voltage here? To do this, notice, okay, the left side of the circuit, this 4 ohm resistor has no current flowing through, right? Because it's not connected to the circuit, only part of it is. So essentially the voltage at B is the voltage across this 2 ohm resistor. So VB is equal to 10 amps on through times 2 ohms is equal to 20 volts. So this voltage here at B is 20 volts. Now let's find the voltage here at A. The voltage here at A is the voltage across this 2 ohm resistor. If we use the voltage divider rule, or VA, is equal to your resistor divided by the total resistance times your voltage being divided up, the voltage divider rule. So that's equal to 2 volts. Okay. So essentially, that the voltage here across this open capacitor is VA minus VB. Okay, so VA minus VB is equal to this voltage here, your initial voltage before the switch is closed. So it's 2 minus 20 is equal to negative 18 volts. That's equal to your initial voltage. We could call that VO. Okay, VO for 0 minus before the switch has been closed. Okay, now that we found the voltage for when the switch is open, I'm going to find it when right when the switch is closed. We're going to find the voltage here again. Now when it's closed, we only care about the right side of the switch, right side of the circuit, because this is isolated. This left side is isolated by this ground wire. Okay, let's redraw the circuit again. We have plus. This is for when T is greater than 0. When the switch is closed, we have our 6 volts, 4 ohms, 6 volts, 6 volts, 4 ohms, 2 ohms, and our capacitor. This is 0.1 farads. Okay, let's find the voltage. Okay, so the voltage across this capacitor under for a long time when T is greater than 0 is our final voltage. When T is greater than 0 equal to the voltage. Though this pops open because for a long time when it's steady state, capacitor pop open. So it's 2 over 2 using voltage dividable, our 2 ohm resistor divided by its equivalent resistance times voltage being divided up is equal to 2 volts. Okay, and now we want to find our tau. To find tau is RC, right? Tau is equal to RC, R Thevenin's, really, times C. What's our R Thevenin's in this case? It's this 2 ohm resistor in parallel. It's actually in parallel if we use a shortcut. Okay, so we cut this here at A, cut this at B, and if we short this, because we have independent sources, we have that the 4 ohm resistor is in parallel with the 2 ohm resistor. So R Thevenin's is equal to 1.33 ohms. Okay, so now that we have our Thevenin's, we can find tau. Plug in our Thevenin's into here, and our capacitance, 0.1 farads, we have 1.33 times capacitance 0.1 farads equal to 0.133 seconds. Okay. Now we have all required. We have initial voltage, we have a final voltage, we have a tau. We can finally write it in as our general solution. Okay, let's do that quickly. So the voltage across the capacitor for all of time is equal to your final voltage 2 plus your initial voltage minus 18 minus your final voltage e to the minus t over tau, 0.133. Okay, and that is our general solution for this RC circuit. RC circuit, and that's how we do it. Thanks for watching.